Welcome to Year 7 Maths videos. As always, I encourage you to skip forward anything you already know or watch on a faster speed if that suits you. Alright, welcome to Unit 4, Fractions and Percentages. So the first part in 4a is what are fractions? Well, fractions are wholes or sets that are broken up into parts of that. So here it's very, very basic revision. Here we have one whole cut into 4 pieces, and you have the shaded part, and so there's how many parts equal the whole, and there's 4, and this is how many there are altogether. The number of shaded equal parts, which is 1, because there's only one of them, and then the fraction shaded is 1 out of 4. That's how, or 1/4. That's how they work. Now, that's super basic, but I think you should know that. Represent the following fractions on a number line. So, as you can see here, when you do this, you have to, you have your little stages, and you can write like 1 whole, 2 wholes, 3 wholes, whatever, 0 on there. But because you see here that they're thirds, they're out of 3, each whole needs to be cut into 3. So you put in your little things there, and then that's 1/3, 2/3, and that's 3/3, which is the same as 1. So you can do either one, it doesn't matter. Then you cut this into 3, so you got 4/3, or 1 1/3, whatever you want to say, 5/3, and then 2, which is also 6 out of 3. And goes so on and so forth. But the way you put that on the fraction line then is you simply, where's 2/3? Well, there's 2 out of the 3 cut of a whole, so that's where 2/3 is. And then you say 5/3, well that's here, because that's a whole plus 2 more thirds, so that's 5/3 there. Okay, writing stuff in simplest form. Okay, simplest form is very important, and the way we do that is finding the highest common factor between the numerator at the top and the denominator at the bottom. So usually a good way, like I said in Unit 3 video, a good way is to start seeing if you can divide both the numerator and the denominator by the smaller number, which is usually the numerator, except for in improper fractions. So we try here. Can you divide 2 by 2? Of course you can. Can you divide 6 by 2? Yes, you can. So divide by 2, both of them. 2 divided by 2 is 1. 6 divided by 2 is 3. And that is the simplest form. Here, 6. Can you divide 21 by 6? No, you cannot. So you go down the next factor of 6. Well, the next factor of 6 is 3, because you can do 2 times 3. So you say, oh, I divide by 3. Can I divide 21 by 3? Yes, I can. So that's the highest common factor. That's what you divide by. So divide by 3. So you have, divide the top by 3, which is 2. And you divide the bottom by 3, which is 7. And you cannot do it again. So that's your answer. And here, 12 and 16. Can you divide by 12? No, you cannot. Can you divide by the next factor of 12, which is 6? No, you cannot. What about the next one down, which is 4? Yes, you can, because 4 times 3 is 12, and 4 times 4 is 16. So divide by 4, divide the top by 4 is 3. 12 divided by 4 is 3. And divide 16 by 4 equals 4. So you end up with 3/4, and they're all simplified. You cannot divide them anymore. So how do we convert these mixed numbers into improper fractions? Well, here's a mixed number. Effectively, what you're trying to do here is there's 5 pieces make up a whole, because that's what the denominator means. That's how many pieces make up a whole. And you've got a whole here, which means what you need to do is you need to times 1 by 5, times 1 by 5, which is 5, and you need to add that to the top. So that's, or the numerator. So that's 4 plus 5 is 9, so it's 9 out of 5. That's how it's an improper fraction. So you just times the whole by the denominator and then add that to the numerator at the top. And in the same way, converting these into improper fractions, you have to divide 9 by the denominator. So if you do that on the calculator, it's going to give you 2.25. that's not really good for you because it's a fraction. So you can see how many 4s go into 8. Well, there's 2, because 2 times 4 is 8, and then the leftovers between 8 and 9 are 1, so 2 1/4. So there's 1 piece left over and the denominator stays the same. That's how you do improper to mixed. Okay, place the fault. Now we've got to order fractions in 4D. Okay, ordering fractions. That requires you to find the lowest common multiple, because you've got it. Sorry, when you order fractions, these ones might be easy for some of you, but you really need to make them all out of the equivalent, or not equivalent, sorry, but they need to have equivalent denominators. They need to be out of the same amount. So to do that, out of the denominators, you have to find the lowest common multiple, or denominator rather, it's the same thing really, lowest common denominator in this. So the way you do that effectively, you could times them all together. You could times them all together, and then you times the top by that 2, and you could do that to find out what the denominator is. So you get 2 times 3 is 6, 6 times 5 is 30, so they'd be out of 30, and then you'd have to say, well, what do I times? If I times, would I have to times 2 by to get to 30? I times 15, so I have to times the top by 15. What do I have to times 3 by to get to 30? 10, so I have to times the top by 10, and then what do I times the 5 by to get to 30? I have to times it by 6, so you times the numerator by 6, sorry, and then you'd be able to compare them after that. But that's not always the best option. There might be a number earlier that they list in, so you can list them out: 2, 4, 6, 8, 10, 12, 14, 16. Let's see if we can 3, 6, 9, 12, 15, 18, 5, 10, 20, or 15, sorry, 20. Now nothing is the same yet, so we've got to keep going. 25, 30, and here you go 21, 24, 27, 30, and here you keep going up. And spoilers, this time when it always goes higher when there's 3 numbers. It is actually 30. So to get it, yeah, again, you have to think, what do I need to times the bottom by to get to 30? We already said that, so times 15, you have to times the top 2. Times 10, times 10, times 6, times 6. So then it comes out as 15 over 30, 20 over 30, and 18 out of 30. And now you can order them in ascending order. And ascending means going up, ascending. So this would be first, this would be second, and this would be third. And that's the way it is. Based obviously on their top number, because they've already got the same denominators, so then just what is the biggest numerator is the correct answer. Alright, adding fractions. If you have a fraction like this, very easy. It's got the same denominator, you just add the tops and leave the denominators the same, no worries. 5 over 7, that's it. Very simple. The tricky thing is when they have different denominators. Now, the way you do different denominators is by finding that lowest common denominator. So 3 and 5, where is their lowest common denominator? Where is their lowest common multiple? So if you need to, you could times it together. 3 times 5 is 15, and that is actually the lowest common multiple in this sense, but it's not always. So you can list them out: 3, 6, 9, and so on, and then 5, 10, but it is 15. So then what do you have to times 5 by to get 15? Times it by 3, which means you also have to times the top by 3. What if you times 3 by to get to 15? You have to times by 5. So you also times this by 5, which comes out with 5 over 15 plus 9 over 15. Now you can add them. So you say add them together. 5 plus 9 is 14. There you go. Now, with this part here, with mixed numbers, what you actually can do when you're adding them is that, unless they want you to do it as an improper fraction, which adding, you can just actually ignore the wholes, because they're already wholes. It doesn't matter. It doesn't matter if they're out of 30, out of 40, out of 3, it doesn't matter. They are equal. Because it's the same, doesn't matter. So you can actually take them out for addition only. Not always, not for multiplication and stuff, but for addition you can. They're wholes, but then you're looking at the 2/5 and 5/6. Now again, you have to make them into the same denominator, and the first number, the first lowest common multiple they have is 30 again. So you go times 5 by 6 to get 30, and 6 by 5, which means you times that by 5, and times that by 6, rather. So then you have 12 over 30 plus 25 over 30. You add them together, they equal 37 over 30. And you still have these wholes, so it's actually 6 and 37 over 30, but that's not finished yet because 37 is too many. That's another whole. So you take 30 out because 30 makes a whole, makes it a 7 and 7/30ths. And that's how you do that one. Alright, subtracting fractions is very much the same. You just have to make them equivalent. And by equivalent, I mean having the same denominator, sorry. And to do that again, you have to find out what's the lowest common multiple. And for 2 and 5, it's 10, spoilers. So again, you can do that by listing out the multiples. 2 times 5 is 10, 5 times 2 is 10, which means you also have to times that by 2 and that by 5, sorry, because you've got to times the numerator and the denominator by the same thing. Which brings out 6 over 10 minus 5 over 10, which obviously equals 1 over 10. That's all there is. Now the same thing with this, I put this one in here because it's a bit tricky, right? So you can actually just do the whole straight away. So 3 and 6 leaves you with 3 and 3/20ths minus 2/3. Now you have to get these the same, so 20 and 3, where do they get the same multiple? It'll be 60. 60 is the lowest one, so you have times 20 by 60. Now, if some of you watching this go, how do you figure that out? Again, just write it out if you have to, or again, you can just times one by the other will always get the right answer, but then you'll have to simplify later. So you can do that if you need to. So times 3 times 3 times 20 times 20 comes out with 3 with 9 over 60 and minus 40 over 60. Now, here's where you come into a problem, right? So 9, you can't subtract 40 from 9, it's not going to work, so you're going to need more. So then what you need to do is you need to take a whole. Remember, when you take a whole, it turns into as many pieces as what's there, which turns the 9 into a 69, and now you're doing 69 minus 40. So that equals 2 and 29 out of 60, and you can't reduce that anymore. You can't divide the top and the bottom, so that is the simplified fraction of that. Now, this case, it's okay. You can just times them by each other effectively. That's what you've done. But that may not always be the case. And because that way, if you look at it, look, that's timesing there, and that's timesing there. This one's getting times by 20, and that one's getting times by 3, and then you have to times them by something different. Well, times them by each other. So you can figure it out that way as well, timesing it like that. But it doesn't necessarily always get you the simplified answer, so that's your choice if you want to do it that way. But in the book, that's the way it was talking about, finding the lowest common multiple first, which often is just timesing the two together, but not always. Alright, 2/3 of 36. How do we find that? This multiplication. What you're effectively saying is 2 out of 3 times 36 out of 1. That's what you're saying. Now, this is quite easy. This, in fact, is weird because in primary school timesing is harder. But in this one, you just times them out. But before you times it out, you have to check your cross multiples, which I know some of you are loving. So cross multiples like this and this, you check, compare them, right? So 1 and 2, they're nothing. But 3 and 36, is there a highest common factor between them for simplifying? Well, there is. You can divide by 3 and divide by 3, which leaves you with 2 still. The 3 divided by 3 was 1, and then 36 divided by 3 is 12 divided by 1, which equals 24 over 1. You're done. Except you don't really need the 1. You can just do 24. This one here, you times it up first, and you don't have to do it that way. If you want to, you can simplify it. I'm not going to even show it to you because I said in class how it makes it complex if you think, oh, I'll just times these two together. I'll times that and I'll times that, and then I'll just simplify it afterwards. Well, it's not that easy to do. I would recommend, I'm not going to bother showing you now why it's not, but it isn't that easy to do. It's easier to do this, especially if you don't have a calculator, but even if you do. So how can you divide them? Well, you can divide by 4, and these two, how can you divide them? Well, you divide by 3. We already did that prior. So, and you divide by 4, you divide by 3. So 21 divided by 3 is 7. 4 divided by 4 is 1. Times 8 divided by 4 is 2. And 6 divided by 3 is 2. So, that's 14 over 2. Now, there are situations where you've minimized as much as you can, and the reason for the fact that this is the case, they're improper fractions, has an impact on that, I believe, because the numerator is bigger than the denominator. That's not done yet because you can actually divide both 14 and 2 by 2, which would equal 7. That would be your final answer. If you got this, that'd still be good, but to get your full marks, you'd have to come up with 7. Now with this, 1 and 1/7 times 1 and 2/9, you can't do what you do with subtraction and addition and just like do the wholes first. You have to turn them into improper fractions. Now we do that again. The 1 times 7 is 7. So you add that to the 1, and that equals 8 over 7. And 1 times 9 is 9, plus the 2 is 11 over 9, and then you times. Now you check your crosses. There's nothing they can divide by. Check your crosses, nothing you divide by. So you come up with 88 over 7 times 9 is 63. And then you see if there's anything you can do, if there's the highest common factor in these. Now, I think the highest common factor is 1, which means they could not be divided by the same thing. But let me clarify. They can't be divided by 2, they can't be divided by 3, and so on. So that should be the final answer, except if you want to make it, I don't know if they have to, if you want to make it a mixed number again, you'd have to have 1, and then you've got to take 63 for the whole off of 88, which would leave you with 25 over 63. That would be the final answer for that if you needed to put a mixed number. Say the reciprocal of each. It's just swapping it around. 5 out of 1. 2 out of 7, 7 out of 2. That's all it is. That's for division 4h. And then this is where it comes up. 3/4 is really divided by 3 over 1. Okay, really is what it is. But remember, we don't actually ever divide. We just do the reciprocal, swap it around, and then we times it. So that would equal 3 over 4 times 1 over 3. And again, you do your cross checks, so you can't do any of that. And then that you can divide by 3. Divide by 3, which equals 1/4 times 1 over 1, which just equals 1/4. That's what 3/4 divided by 3 means, because you actually, what you're really doing is just dividing that by 3, effectively. 3 pieces, you separate them into 3. That's what it is. Alright, that's how you do. That's how you do dividing. It's just basically multiplication, but swapped around. Then this one, for I, it is, express the percentages as fractions in their simplest form. Now, when you do these, there's a certain thing you've got to do. It's all about timesing by 100. So if you have 11%, it's really 11 out of 100. Okay, that's what it is. But then you need to see if you can divide the top and the bottom by the same thing. So we do that. Basically by simplifying the way we've been doing. Can you divide them both by the same thing? No, you cannot. So it's left as 11 over 100. 71 over 100, you can't change it. You can't change it. 25 you can change, 25 over 100. When you say can I divide them both, you start with the top, the high number, remember? Or sorry, the low number at the top. Can you divide by 25? You can. Can you divide the bigger number by 25? You can. Therefore, you do that. And that would equal 1 over 4. And that's your simplest form version of that. Now, express these percentages as mixed numbers in their simple form. Now, obviously, anything over 100 is a whole. So there's 2 wholes, 4 wholes, 1 whole, and so on and so forth. So that would mean that is really 1 and 20 over 100. So then you need to say, well, can I divide these by anything? Well, can I divide it by 20? Because that's the highest common factor. Well, yes, I can. So that would equal 1 and 1 over 5. That's what you could do. For 237, you have 2 and 37 over 100. And you can't divide 37 and 100 by anything the same, so that's done. 175% would be 1 and 75 over 100. You can divide both of these things not by 75, so you go down. Well, the next thing down is 25, so you can divide by 25, divide by 25, and then you say, alright, equals 1 and 1 and 3 over 4. It's 1 3/4, that's what it is. But how do you get an eighth? How do you get a fraction to a percentage? Well, basically you times by 100, because that's what it is, you times by 100. If you did this in a calculator, if you did 1 divided by 8 times 100, you get the right answer, which is effectively what it is. So, but it's really 100 over 1, because every whole number is technically over 1. It just makes it easy. So that would make it 100 over 8, effectively, but then you've got to simplify. Now, what can you divide these both by? The highest you can't divide 100 by 8, so you divide it by 4, which would equal 2, and then divide that by 4, which would equal 25. 25 over 2, that can't really be made smaller, but if you want to turn it to percentage, you can't have 25 over 2, so you still need to get it to a percentage, so you do need to then halve it. So the way you halve it is, if you're doing a calculator, it'll come with 12.5, so 12.5% is the answer to that one. 1 and 3/20. Obviously, 1 means 100%, so you already have that, hopefully, sorted out. Then you say 3 over 20 times 100. Now you could do that way, or you could put the 1 in the 20 to make it 23 over 20 is 100. We'll do that for now, just in case you don't get it. So you go across, you can't do anything there. Here you can divide by 20. So that makes that 1 and makes this 5. So then 23 over 1 equals, times, 5 over 1 is times that across. That would be 115%. That's what it is. Alright, express the following as both a fraction of the simplest form and a percentage of the total. So 18 of a total, this is from 4J now, 18 of a total of 30. So 18 over 30, what can they divide? Can they divide by 18, both of them? No, they cannot. The next factor down is 6. Let's say divide by 6 equals 3 over 5. Done. Alright. Then you got the percentage. Now you could do it from this fraction, but I would rather do it from the simplified fraction. So that's 3 over 5 times 100 over 1, because it's a percentage. So that you can do cross multiples there. Check the lowest number. You can both divide by 5. Both divide by 5. So that makes 3 over 1 times 20 over 1, which equals 60%. Like magic. Alright, ratios. Simplify the same way as you simplify fractions. You have to be able to divide both sides by the same thing. So you start with a smaller one, you say, can you divide the big one by the same one as the smaller one? Well, you can. Divide by 3, divide by 3, it works. So 3 divided by 3 is 1, 9 divided by 3 is 3, and so it's all equal. Same with 5 and 10. Can you divide it? Yes, you can. 5 by 5. So 5 divided by 5 is 1, 10 divided by 5 is 2. And so there are your ratios. So if I have 1 cup of sugar, you have 2 cups of flour. So if I have 2 cups of sugar, I'll have 4 cups of flour, because the ratio is all equal. Because whatever you do to one, you have to do the other, just like in fractions. Times by 2, so you got to times the other one by 2. Divide by 2, you got to divide the other one by 2. You can't do adding though. It has to be times or divide. Here, how can we, this is rates now. How do you do rates? Well, you have to get it down, they all have to be $1 a kilo. So we did this one in class, but how do you get 500 grams to a kilo? Well, you got to double it. So therefore you got to double that too. So times by 2 would have you at 1 kilogram for, and then $2.09 times 2, you can use the calculator, 4.18, you shouldn't need to, but it's there. So that's 1 kilo for 4.18. Here is 19.95 for 5. That means you have to, and how do you get 5 to 1? You divide by 5, which means you divide that by 5. Which means the price would be $4.99 a kilo. Again, you can put that in your calculator if you need to. 2 kilos for 7.80. How do I get 2 kilos to 1 kilo? You divide by 2. Divide by 2. Which means 1 kg for that. So if you divided, again, you can put in the calculator. This is 8 divided by 2 would be 4, but it'll be like 3.95. Alright, and then again divide by 10, it would be 3.8 dollars, 3.80 cents. Right, because when you divide by 10, you just move the decimal point over that way. A few times you do it the other way, whatever. Last one, last section. Good job sticking with it. This turned out to be a long video, but oh well. So simplify the following rates. So you want to make them simplified. So you say 24 in 2 hours. Well, how do I get? I got to get one of them to 1 ideally. So 2 is a small, so I get that to 1. And because you don't want to know how many hours per kilometre, you want to know how many kilometres per hour. So you divide that by 2 to get to 1, which means you also divide 24 by 2 to get to 1, which means you'd end up with 12 in 1 hour. B would be clapping 120 times in 30 seconds. Well, I suppose you want to get to 1 second, or you can get to, doesn't actually say to what rate. So you could either get it how many claps per 1 second, or you could even get it to how many claps per 60 seconds, which is a minute, because 1 minute you want to get down to 1. So let's just do this, divide by 30 for 1 second, divide by 30, 120, that obviously equal 40 in 1 second. No, not 40, sorry, 4, my bad. 4 in 1 second. Then here, 28 and 4, you divide by 4 would equal $7 in 1 kg of lollies. Alright, that's it. Hope you enjoy these videos. They might not be the most riveting thing, but they could be important to you.